Hello guys, welcome to my channel. I am your presenter, H squared. Right, the GCSE mathematics topic I'll be covering today is factors, highest common factor, the lowest common multiple, and prime factors. Right, now we will be showing you how you can use the knowledge to solve exam type questions. But first of all, I'll talk you through the concepts of what factors are, highest common factors are, lowest common multiples are, what prime factors are, what prime numbers are, and how these can be calculated in order to find the required answer in an exam. So after talking you through the concepts, guys, we'll go on to look at specific exam type questions. Okay, right, if you like the video, guys, if you find the videos helpful, please like them and subscribe to the channel so that you are informed of the new video uploads. That will actually be very helpful. Right, let us now get started. Lowest common multiple. Right, okay, so this is what we're going to be covering in more details, guys. I'll talk you through all the concepts, right, involved under this topic so that you can understand more and know how to apply them. Then later on I'll give you examples, guys. So we'll be looking at what multiples are, what factors are, and the meaning of lowest common multiple and how to find them, and the meaning of highest common multiple and how to find them. Okay, by the end of the lesson, guys, right, you should be able to know the difference between multiples and factors, factors and prime factors, and then you should be able to find lowest common multiples of at least two numbers, and also be able to find the highest common factors of at least two numbers. Okay, right, now with this knowledge, guys, you'll be able to solve GCSE exam questions such as these ones. Right, this is just an example of the questions that you might find under this topic, guys. We'll go through all of them after I've finished talking you through the concepts underpinning this topic. Okay, now let's look at the factors, guys. Factors are numbers that divide a number exactly without leaving a remainder. Okay, if we look at the factors of 15 there, guys, you've got 3, 5 and 15. These are the only numbers that can divide 15 exactly without leaving a remainder. And then if you look at 12, its factors are 2, 3, 4, 6 and 12. These are the only numbers that can divide 12 exactly without leaving a remainder. Now some people might ask, why have I left out 1? 1 seems to be a general factor. It is a factor of all the numbers, and therefore it is not really necessary in solving. It doesn't change anything in solving mathematical problems. That's why it's normally left out. Okay, you understand later on when we start looking at factors, prime factors, HCF, LCM in details, why 1 is actually normally left out, because it simply doesn't change anything. Right, then if we look at the prime factors, apart from factors, we've got prime factors. Now prime factors are prime numbers that can divide a number exactly without leaving a remainder. Now remember, factors are just numbers, prime factors are prime numbers. That's the difference there. They are prime factors have to be prime numbers that divide a number exactly without leaving a remainder. And now, if you understand what a prime number is, you should be able to find the prime factors of a number. Prime numbers are those numbers whose factors are only 1 and itself. What that means is it's a number which is divisible exactly by 1 and itself. Right? Such numbers are 2, 3, 5, 7, 11, 13, 17, etc. Right? The list goes on and on, guys. As long as a number has only 2 factors, 1 and itself, then that's a prime number. Okay? Or, in other words, you can say a number that is exactly divisible by 1 and itself. That is a prime number. Okay? Now, in the case of the 2 numbers whose factors we found on top, we've got 15 and 12. These ones here are the prime numbers. 3 and 5 are the only prime numbers of 15. These are the only prime numbers that can divide 15 exactly. Therefore, these are the prime factors of 15. For 12, its prime factors are 2 and 3. These are the only prime numbers that can divide 12 exactly without leaving a remainder. Okay? Right, now let's look at what multiples are. Right. With multiples, guys, these are a product of a given number. And numbers 1, 2, 3, 4, 5, 6, 7, 8, etc., etc. Right. For example, you've got multiples of 5 here. You've got 5, 10, 15, etc. All these have been found by multiplying 5 by 1, 2, 3, and so on. Right? If you multiply 5 by 4, you get 20. So 20 is one of the multiple of 5. Right? So all these are multiples. So this is one of the ways of finding multiples of a number, guys. Okay? You simply times the number by 1, 2, 3, 4, 5, and then you can see what the multiples are. Okay? Then when it comes to the highest common factor, right? Now the highest common factor is the greatest factor that can divide at least 2 numbers exactly. Right? The highest factor that can divide at least 2 numbers exactly. And that number that can divide a number is commonly known as a divisor. So under highest common factor, guys, we are looking at a divisor. Okay? I'll explain in details what a divisor means, but you should understand any number that can divide another number is known as a divisor. Okay? So here under HCF, we are looking for the greatest factor that can divide at least 2 numbers exactly. Now for the lowest common multiple, guys, we are looking at the lowest dividend or the lowest divisible number that can be divided at least by 2 numbers. I didn't say that correctly, guys. Let me go through it again. This is the lowest number that is divisible exactly by at least 2 numbers. Okay? It will become clear when I give you examples, guys. Now, under lowest common multiple, what we are looking for are dividends. Right? Remember, for HCF, we're looking for the divisor. We're looking at the divisor. And here we are looking for the dividend. The number that can be divided. The lowest number that can be divided exactly by at least 2 numbers. Okay? I hope that makes it clear, guys. But don't worry, as we go through. Right, guys, now that we've looked at the concepts, I hope you understand all the concepts that I've been able to explain. If there are any issues, guys, leave us a comment in the comment section. Now, after having looked at the concepts, guys, let's start looking at the actual examples of the exam type questions that you might come across I'll talk you through how to solve them. I'll solve them with you, and I'll show you the various methods that I'll use actually to arrive at the correct answers. Right, let's get started, guys. Okay guys, let's get started looking through the exam type questions under this topic. Right, now question number 1 has a list of 6 numbers there, and it's asking us to write down 2 numbers from the list, from that list there, with a sum of 51. Now here, just look at the 2 numbers here. Of course, this one is too big, it's above 51. That one is over 51. This one is close to 51. So these are excluded automatically. Right, 34 and 17, or 34 and 12 are the likely numbers there. Already you can see 12 and 17, they only give us 29, which is far less than 51. So the number definitely has to be 34 and 17, right? So 34 plus 17, the answer is 51. Okay, because 4 plus 7 gives us 11. We put 1, and then we keep 1. Then 1 plus 3 is 4, plus that 1 gives us 51. Okay, then B, write down a number from the list which is a multiple of 9. Remember, I talked about multiples of 9, right? From this number, which one of the numbers can actually be multiplied by 9 and 1, 2, 3, 4 to get one of these numbers here? From what I can see, 12 is completely out. Okay, 17 is completely out. 34 is completely out. 49 is completely out. You've got 69 there. Right, now 69, you think of 69. Can 69 be divided by 9 exactly? I doubt it. But if you have 9 times 9, what you get there is 81, right? If you take out 9, you're left with 2 and 7. It means 1 9 here has been taken out. You're remaining with 8 9s. So the number that is a multiple of 9 is 72, because 9 times 8 you get 72. A square number. Now a square number is simply a number which can be found by multiplying 2 equal numbers. From what I can see there are no 2 equal numbers that can be multiplied in order to get 12. We're talking about whole numbers, not decimal numbers or fractions. Okay, that's what we're talking about here. So this one, no. 17, no. 34, no. 49. If you go through your times table again, you discover that square number can actually be found by finding the square root of that number. So the square root of 49 is equal to 7, because 7 times 7 gives us what? 49. Remember, I say the square number is a number that is found by multiplying 2 numbers that are exactly the same. So 7 and 7 are equal. So 7 times 7 gives us what? 49. So the square number is 49. Then C says circle the correct word that completes the sentence correctly. 17 is it a cube number? No, a cube number is a number that can be found by multiplying 3 equal numbers. Like if you multiply 3 times 3 times 3, you find 9. 9 is a cube number. 17 is not a cube number. 17 is not a multiple, right? 17 is a factor, yes, of 34. It's not a product of 34, but it is a factor of 34. It is a factor of 34 because 17 can divide 34 exactly without leaving a remainder. 2 times 17 will give us 34. So the correct answer is factor there. Here are 9 numbers, right? You've got the 9 numbers there. From the numbers on the cards, write down 2 multiples of 7. Multiples of 7, these are numbers that can be found by multiplying 7 by 1, 2, 3, 4. 4 is less than 7, so that's out already. 14, yeah, because 14 times 2 is there, right? Which other number here? 19, no. 20, no. 25, no. 42, yes, because if you go like this, if you multiply 7 by 1, by 2, 7 by 3, 7 by 4, 7 by 5, 7 by 6, that is 7, that is 14, which we've got there. This is 21, we don't have 21 there. And that is 28, we don't have 28 there. That is 35, we don't have 35 there. We've got 42, which we've got here, right? So that is 42, that's the second one. Okay, these are the multiples of 7. 3 factors of 100. Now factors, if you remember, are those numbers that can divide 100 exactly without leaving a remainder. So you look at numbers that can divide 100 there. 4, yes, 4 can divide 100 because 100 divided by 4 is actually 25, and 25 is one of them, right? And 20 is one of them. So you've got 4, 20 and 25, 3 of them, right? Each one of these numbers can actually divide 100 exactly without leaving a remainder, right? Now 3 numbers from that card that are both a square number and a cube number. Square number and a cube number. Remember, a square number is a number that is found by multiplying exactly 2 equal numbers. 4 is a square number because 2 times 4 times 4, no, 2 times 2, sorry, beg your pardon there, 2 times 2 will give us 4. Therefore 4 is a square number. 14 is not a square number. There are no 2 numbers that are equal that can be multiplied together to get 14. 19 is not. 20 is not. 25 is, because if you times 25 by 5 you get what? 25. So 25 is a square number. 42 is not a square number. There are no 2 numbers that are exactly the same, or 2 equal numbers that can be multiplied to get 42. So that one is out. Then 64, we know that 8 times 8 will give us what? 64. Therefore 64, 25, 4 are square numbers. These are square numbers here. Okay, these are square numbers. Now cube numbers. Cube numbers are numbers that can be found by multiplying 3 equal numbers. 4 is not, 14 is not, 19 is not, 20 is not, 5 is not, 42 is not, 64 is, because if you times 4 times 4 times 4 you get 64. 4 times 4 is 16, 16 times 4 is 64. So there is only 64 as the correct answer there. Okay, I know these concepts like square number, cube numbers, I've not dealt with them, but they're very simple to understand. You can know them actually, but if you want to know more about both square numbers and cube numbers, you can simply do a research. These are very simple for you to understand, but I've explained. If there are any questions to do with cube and square numbers, please leave a comment in the comment sections there, and then I'll be able to get back to you and explain what they are. Right, now 3, express 132 as a product of its prime factors. Product of its prime factors. What this question means is you need to find the prime factors of 32 and then write them in a way that they show they are multiplying with each other's. So the first thing we have to do is to find what the prime factors of 32 are. Now, finding the prime factors of 32, guys, it's very simple. This is what you do, right? Okay. This is what we shall do here. You simply write 132 there, draw one complete line there, vertical line, and then draw one line across. So what you start doing is dividing 132 with prime factors, with prime numbers, not prime factors. You divide 132 with prime numbers. So the first prime number is 2. Okay? So 132 divided by 2, you have 6. Okay? Then at this stage, we can continue dividing by 2. 2 into 66, we get what? 33. Then again we divide 33 by a prime number. This case 2 cannot divide 33 exactly, so that's not a good prime factor there. So we look for 3. I think 3 can. 3 will give us 1 1 there. Okay, and we don't have any other number now, any prime number that can divide 11 exactly apart from itself. Okay, that's the only prime number. So 11 can only be divided by 11. Okay, so you have 11 into 11, it gives us 1. Now these are the prime factors. If you times 2 by 2 by 3 by 11, you get 132 exactly. No doubt about that. Then these are the ones that you get, guys. So we write them in this way: 2 times 2, that 2 times 2 times 3 times 11 times 3 times 11. We've now expressed the prime factors of 132 as a product of its prime factors. Okay? 3 marks for that question. Why? Because of the working that is involved there for you to identify the prime factors and then express them as a product. Right, that is done. Now number 4, work out the highest common factor. That's HCF of 12 and 28. Right, so here we have to use exactly the same method, guys. We start with that method and then I'll show you how we can get to the HCF. So you write 12 there. First of all, let's find the prime factors of 12. Okay, we start with the lowest prime number, which is 2. 12 divided by 2, it gives us 6. Okay, then we can divide 6 by another 2 there. 6 divided by 2, it gives us what? 3. Okay, then the only prime number that can divide 3 exactly is 3 itself, to get what? 1. So the prime factors of 12 are 2, 2, and 3. I am now expressing them as a product of its prime factors. Okay, I'm expressing 12 as a product of its prime factors. And I'll do the same for that one as well, for 28. So I'll write 28, draw a line there, then start with the smallest prime number, which is 2. 28 divided by 2, it gives us 1. 1 and 4. Okay, that's 14. Then 14 is divisible by 2. 2 is the prime number. 14 divided by 2, you get 7. Now 7 itself is a prime number. There isn't any other prime number that can divide 7 exactly apart from itself. So we divide that by 7 and we get 1. So these are the prime factors of 28. So that is 2 by 2 by 7. Okay, now after having done that, guys, what you do is you can write them here. I'll write them here for you to see. Okay, that is 2. No, let me write it properly for you to see clearly what is going on here. Okay, I have 12 there and I have 28 here. So prime factors of 12 are 2 by 2 by 3, and prime factors of 28 are 2 by 2 by 7. Now our task is to find the highest common factor. So highest common factor means we simply have to get those that are common both sides. So we've got 2 there, that is common. We've got another 2 there, that is common, right? 3 is not common both sides, 7 is not common both sides. So we leave these ones out. So the highest common factor will simply be 2 times 2, which will give us what? 4. And 4 is the highest common factor. This is the highest factor that can divide 12 and 28 without leaving a remainder. Okay, let me write this properly, guys. Right, yeah, that's how you find the highest common factor of 2 or more numbers. Now let's look at number 5. Number 5 is asking us to find the lowest common multiple of 10 and 18. Now the same method applies in this case, right? You find the prime factors of both numbers, you express them as a product of their prime numbers, and then you do like what I did, but it's slightly different. Instead of taking the common ones here, right, you cancel out the common ones on one side and multiply all of them together. I'll show you how that works. So you start by writing 10, draw some lines there, then we start dividing by the lowest prime number. How many 2's are in 10? Or 10 divided by 2, you get 5, right? Now there is no any number that can divide 5 exactly apart from itself. So we put 5 there. 5 divided by 5 will get 1. Therefore 10 can be expressed as 2 times 5. Then we look at 18. We do the same as well. We start with smallest prime number. Divide 18 by 2, we get what? 9. Right? And then what number can divide 9 exactly, which is a prime number? 2 can't. Definitely is 3. So only 3 can divide 9 exactly. Right? So 9 divided by 3, you get 3. And then at this stage, there is no any other number that can divide 3 exactly, which is a prime number. So only 3 can do that. So 3 divided by 3, you get 1. So 18 can therefore be expressed as 2 times 3 times 3. Right, having done that now, guys, how do we get the LCM? This is the tricky bit that you need to understand. Please, you need to practice doing this several times. Give yourself 30 minutes, an hour every day for you to get used to these things, because mathematics is a highly practiced subject. Without constant practice, you lose track. Okay? Now, in this case, right, we look at those that are common. Right, 2 and 2 are common, so we cross out 1 from one side. We keep the 2 there. Right, then we bring down the 5 because it's not common. 3 here is not common. 3 there is not common. Okay, so you only cancel out the common numbers from one side and then bring down all the numbers that are remaining, multiply them to get the lowest common multiple. So in this case, we've got we've got 10 times 3, that is 2 times 5 is 10, 10 times 3 is 30, 30 times 3 it's 90. So our answer here is 90. Okay, and if you multiply 10 by all the numbers that you can get there and multiply 18 by all the numbers, you'll have a long list. The lowest common multiple that you get that is common for both numbers will be 90. Now this is the shortest algorithm that you can use to arrive at the answer. So you can see the difference. Yeah, when we're finding the highest common factor, we're simply looking at those that are common. Right, 2 here is common, 2 is here common, then we multiply the common factors to get the highest common factor. Those that are not common, we left them out. That is in case of HCF. But for LCM, those that are common, we cancelled 1. We cancelled them on one side. You could have cancelled it here or cancelled it here, but you only cancel 1. 2 is common on both sides, so we get rid of the 2 there. Then the rest that are remaining, simply bring them down and multiply them to get what? The lowest common multiple. I hope that is clear, guys. Then we go on to number 6. This is number 6. Typographical error there. Right. Then P and Q are numbers written as the product of their prime factors. They've already been expressed as product of their prime factors. There's Q and P there. So the task for us is to find the highest common factor of P and Q. So P and Q are the numbers. Part of the work has already been done for us. Okay? All what we need to do now is to find the highest common factor. So we write P there, write Q there, and then expand each one of them. So for P, we've got 3, 2 by 5 by 7. Here we've got 2 by 3, 3 by 7, 2. So all you do here is you expand these ones. So this one here, 3 squared means 3 times 3 times 5 times 7. Then 2 here, so it's on, then 3 to the power 3, or 3 cubed. 3 cubed is 3 times 3 times 3. 3 multiplied by itself 3 times. Here it means 2 multiplied by itself 2 times. Then here we have 7 multiplied by itself 2 times. Okay? Multiplied by itself 2 times. Right. So here you have 2 times 3 times 3 times 3 times 7 times 7. We are trying to find the highest common factor. Remember, we only take those that are common from both sides. Right? 3 is common we've got 3, 3. Okay, we've got another 3 and another 3 there. Okay, 5 is not common, we leave it out. 7 and 1 7 there is common. Okay, this other 7, we don't have a corresponding 7 there, so only 1 7 is common, and 2 3s are common both sides. Therefore our HCF, guys, will simply be, our HCF will simply be 3 times 3 times 7, which gives us, that's 21 by 3, gives us 63. Okay, yeah, so 63 is the highest common factor of P and Q. Find the lowest common multiple of P and Q. Some method but different, like what we did before. So we've got P, Q. This P is 3 times 3 times 5 times 7, and that is 2 times 3 times 3 times 3 times 7 times 7. Okay, now when you're finding the LCM, we are simply going to look at those that are common on both sides and cross them out. 3 here, we have 3, that 3 is crossed out. 3 here, we have that 3, and this 3 is crossed out. Then 5, we bring it down because it's not common. 7, we bring down the 7 and we cross out that 7. Okay, then the rest of them, that 3 there will qualify, and that 7 there will qualify because they are not common. And then you've got a 2 here, of course, that is not common. So in other ways, let me just show you another way of doing it instead of what I've done here. So another way what we do is we've got 3, 3 we cross out, we've got another 3, we cross out the 3. We've got a 7 there, we cross out 1 7, right? Then all what remains there, you multiply. So we have 3 by 3 by 5 by 7. By 7, and there's a 2. There's another 3 here, guys, sorry. There's 3 there, and there's a 2. Because we remained with 2, we remained with 3, 3, 3, 7. There's 1, 2, 3, 4, 5, 6, 7 numbers. 1, 2, 3, 4, 5, 6, 7 numbers. So you times all these numbers, guys, to find the lowest common multiple. If you multiply that, that will give us 6. We have 6 here. We have 9 there. We have 35 there. Times 7. Okay. 6 times 9, that is 18 by 3. That's 18 by 3, guys. That gives us 54. Right. Then 54 times 35. 54 times 35. We get Okay, then that times 7 we get okay, so all that by 3 by 3 by 3 by 5 by 7 by 7. Right, the answer is 13,230. Okay, right. Right, so this is basically what you have to do. Once you reach that stage, you simply multiply these numbers and then you'll be able to find the lowest common multiple of P and Q as 13,230. Okay. Okay, right guys, this marks the end of our lesson on factors, prime factors, highest common multiple and highest common factors. Right, if you find this video any helpful guys, please subscribe and like the video and leave some comments in the comment section so that I can deal with various issues regarding this video. If there are any suggestions, improvements that can be done to make this lesson captivating and interesting, please leave us a comment there, because that will help me to make lessons more accessible to a lot of people around the world. Right, thank you very much for watching. See you in the next video. Guys, if you find this video helpful, please like, share and subscribe to the channel to help us. Tip donations are also welcome guys. All you have to do is scan the QR code below. Thank you for watching guys. Looking forward to see you in another video. Thank you.